All right, in this video, we will finish the endocrine system by looking at 4 glands of the endocrine system: the thyroid, the parathyroid, the adrenal glands, and the pancreas. There are other endocrine glands out there, but I'll leave those for your own discovery. For those of you who are curious, I just wanted to kind of hit the high points and the ones that we think about more when we think about endocrine glands. So first, let's look at the thyroid. To orient you here, here's the hyoid bone. Remember, hyoid is the one right underneath the chin. And this is your trachea. And so the thyroid gland is this gland that kind of sits right on the neck. If you're looking at someone and you look at their neck, you can see their thyroid gland. Well, it's behind skin, but you can see where it would be. A trained physician can actually detect problems with the thyroid by looking at an individual just looking at them. It's pretty crazy because the thyroid is just right there on the outside. It's a butterfly-shaped gland, and it's the body's major, it produces thyroid hormone, and it is the body's major metabolic hormone. And so the thyroid is in charge of controlling metabolism through the body. It virtually affects every cell of the body. If you think of metabolism as the combined reactions of all the cells, basically. So this can affect any kind of cell. It's going to elicit different types of metabolic proteins when it is received. And so it can increase the metabolic rate. Typically, the way that it does this is, well, when it increases the metabolic rate, it can cause heat production. And so think of a fever or something like that. This is referred to the calorogenic effect. Calora, so think calories, it's just burning calories. So if you increase your metabolic rate, you can burn calories. And so again, and then the metabolism increases, the brain receives that, thyroid turns off. So you get the idea. And so, you've heard of people having overactive thyroids or underactive thyroids. And so it directly can affect a person's metabolism. Next, there is the parathyroid glands. These are separate glands, but they are on the thyroid. Remember, para means alongside. And so you can see here these parathyroid glands. What you're looking at here is if you could look through a person's neck bone to their back of their throat. This is what you would see. All right. So the parathyroid are these tiny little glands here, and they are embedded in the thyroid, and they produce something called parathyroid hormone. And its big thing is calcium homeostasis, controlling calcium levels in the blood. And so its target organs, if you think about this, where are you going to receive calcium from? Things you eat, things you drink. And so the kidneys and the small intestines are going to need to be involved in that. And also, where do you store calcium? You store calcium in your bones. And so the parathyroid is going to be interacting directly with your bones as well to control calcium levels. Next is the adrenal glands. The adrenal glands are right on top of the kidneys. That RENA, renal, RENAL, stands for kidneys. And so adrenal glands are right on top of the kidneys. They're pyramid-shaped organs. They are paired, so you have 2 of these. And structurally, and functionally, really, it's kind of 2 glands in one. You have the adrenal medulla, and you have the adrenal cortex. And so the cortex synthesizes several different hormones. The adrenal medulla is responsible for the sympathetic nervous system. And so you think about the adrenal cortex is like this, the parasympathetic and the sympathetic systems going back and forth. This area of the adrenal gland, these areas here of the adrenal gland produce 24 different hormones, and these are collectively called corticosteroids, which was a word that was introduced in the last video. Corticosteroids are produced, and we're not going to go into all the different corticosteroids that are out there. But one interesting thing about the steroids that are produced by the adrenal glands, these hormones are not stored in cells, and so their effect depends directly on the rate that they can be made. And so what will happen is the brain tells the adrenaline glands to release hormones, and those hormones are made at a particular rate. And so they can work hard or not hard depending on the circumstance. There's a whole lot here that we are missing out on. But if you're curious, and strongly encourage you to read that. Like I said, 24 different hormones, and they're still trying to figure out what a lot of them do. Encourage you, look at that on your own, but you don't need to know the ins and outs of that. And then lastly is the pancreas. This is a triangular, we'll call it a triangle shaped gland, and it's located behind the stomach. And so to orient you here, ribs, esophagus, this is the liver right here, and the stomach goes here. And so you can kind of see the pancreas right up underneath and in all of that business right there. All right, the pancreas has both endocrine and exocrine cells. All right, let's see. I don't have that picture. For its exocrine function, is a digestive function. It releases a enzyme into the small intestines that can help break down some of the digestive, or aids in some of the digestive processes. We'll talk more about that when we do digestive system. So you just need to know, has an exocrine function that aids in the digestive system. For its endocrine function, there are a set of cells called the islets of Langerhans. Big word there. And these cells are directly responsible for the endocrine function of the pancreas. You have alpha and beta cells. The alpha and beta cells, the alpha cells are what are going to be responsible for producing glucagon, and the beta cells are going to be the ones responsible for producing insulin. And we talked a little bit about these hormones beforehand, but just to go a little bit more in depth here, glucagon, just easy to remember because it's got that first glucose, so think glucose, sugar. So glucagon is a hyperglycemic agent in that it triggers the release of glucose. So if you have a decreased blood sugar, glucagon will trigger the release of glucose from the liver where it's stored. You have this carbohydrate called glycogen in the liver, and that glycogen can be broken down into glucose really quickly. And so this glucagon causes that to occur. And so someone who's diabetic, for instance, these islet of Langerhans cells are what are broken. And so they have to regulate this glucagon insulin release in order to keep their bodies, the sugar regulated. And so glucagon can quickly cause the body to release a lot of glucose, but the glucose, of course, has to be there for them to do that. So sometimes if they're really low blood sugar, the best thing for them to do is just eat something. Insulin has the opposite effect of this. It's secreted into the blood when blood sugar releases or increases, and it can lower blood glucose levels in three ways. It actually enhances membrane transport of glucose into the cells. So the muscle cells, the fat cells in particular, are basically told, hey, go out and get all the glucose you can. It stops the liver from doing what glucagon tells the liver to do. So it turns glucagon off in the liver. Think about it that way. And it also stops the conversion of fats and amino acids. So fats and proteins can also be broken down for glucose, or for the same sort of thing that is going on there. And so those things can be converted to glucose, and insulin will inhibit that from occurring as well. And so basically causing these things to be stored. And so a lot of times people who, this is a total sidetrack, but it's interesting to me. If you, let's say you're eating constantly throughout the day, you keep insulin levels up in your blood, and the body never really figures out it's time to break these things down. It only wants to store them. And so that can cause weight gain. And so insulin levels is also someone who constantly has insulin in the blood. This can cause what is called type 2 diabetes, which is where just your dietary habits are causing the pancreas to actually break down and not work real well. And so you can actually reverse type 2 diabetes by just eating right and exercising. Whereas type 1 diabetes, this is the kind that you're born with. It's typically found in younger people that they have this, and that's just an autoimmune disease where those pancreatic cells are no longer functioning. And here's a picture of just that balance between glucose and insulin. You can look this on your own time, and just pause the video and check it out. But I won't talk about it since I basically already explained it.